Welcome to the DIY Honda Garage channel. The DTC P0557, which stands for Brake Booster Pressure Sensor A Circuit Low Voltage, indicates a problem specifically related to the brake booster pressure sensor in the Honda Pilot models from 2016 to 2022. This diagnostic trouble code points to a low voltage issue in the sensor circuit. The brake booster pressure sensor is crucial for measuring the amount of vacuum in the brake booster, which helps ensure optimal braking performance. When this sensor fails or sends incorrect voltage data to the powertrain control module, PCM, it may compromise vehicle safety by affecting braking efficiency. It's essential to troubleshoot this DTC promptly to maintain vehicle safety and performance measures. Understanding the specific context of the minor electrical issues is critical in addressing this code effectively, as it could lead to significant safety concerns. The brake booster pressure sensor plays a pivotal role in measuring the vacuum pressure in the brake system. Located typically on the brake booster assembly, it provides the brake system data essential for the vehicle's powertrain control module, PCM, to optimize braking pressure. Proper operation of this sensor ensures that the brakes engage smoothly and effectively. The PCM processes this information to maintain vehicle safety and control. When a fault occurs, such as low voltage readings, it may signal potential issues with the sensor itself or the wiring connecting it to the PCM. Therefore, the identification of the sensor's installation site is crucial for effective troubleshooting and further diagnostics. Several factors can contribute to the DTC P0557 error code. One possible cause is poor electrical connections, which can lead to intermittent voltage readings or complete circuit failure. Additionally, loose terminals at either the brake booster pressure sensor or the PCM can disrupt the necessary electrical signals, leading the system to register low voltage conditions. Another likely cause is the failure of the brake booster pressure sensor itself, which can result from wear and tear, exposure to contaminants, or manufacturing defects. Addressing these potential causative factors is essential for restoring proper signal voltage to the brake booster pressure sensor circuit and ensuring the overall functionality of the braking system. Several symptoms can arise when the DTC P0557 is triggered, indicating that there is a problem with the brake booster pressure sensor. One of the most common symptoms is the illumination of the brake warning light on the instrument panel. This light serves as an alert for the driver that there is an issue in the braking system. Another symptom may be poor braking performance, which can manifest as delayed or ineffective braking, posing serious safety risks. Additionally, inconsistent brake feedback might occur, where the driver may experience variations in brake pedal feel, making it challenging to gauge braking efficacy. These symptoms should not be ignored, as they can indicate ongoing issues with the vehicle's braking system and require immediate investigation. In the first troubleshooting step, the vehicle should be turned to the on mode to prepare for diagnostic checks. The Honda Diagnostic System, HDS, should be utilized to check the voltage output of the brake booster pressure sensor. Specifically, you will be looking for voltage readings below the threshold of 0.43 volts. If the readings match the parameters defined, then you proceed to Step 2. If the readings do not meet this condition, the likelihood of an intermittent failure exists. It is crucial to examine for poor connections or loose terminals that may affect the electrical signals sent from the brake booster pressure sensor to the PCM. These preliminary checks are fundamental for assessing the integrity of the voltage signal and ensuring a proper diagnostic flow. For the second step in troubleshooting, begin by turning the vehicle to the off/lock mode. Afterward, disconnect the brake booster pressure sensor 3P connector. This allows for isolated testing of the circuit without interference from the sensor. Next, Turn the vehicle back to the on mode and use the HDS to check the voltage values from the brake booster pressure sensor. Ideally, you should be looking for a voltage reading close to 5.0 volts. If the values meet this threshold, proceed to step 3. If they do not, go to step 5 for further diagnostics. This step is fundamental in isolating the issue to either the sensor or the wiring circuit connected to the PCM, which guides subsequent repair actions. In troubleshooting step 3, the goal is to measure the voltage at specific test points to validate the functionality of the brake booster pressure sensor. Make sure the vehicle is in the on mode and that the brake booster pressure sensor 3P connector is disconnected. Measure the voltage between test points 1 and 2, specifically between brake booster pressure sensor 3P connector number 1 and number 3. The expected reading here is approximately 5 volts. If the voltage aligns with the expected measurement, it confirms that the wiring is functioning correctly and the sensor should be replaced. However, if you do not receive the anticipated reading, you should proceed to step 4 to investigate further. This check is essential to identify if the sensor is the root of the problem or if other wiring issues exist. For troubleshooting step 4, begin by turning the vehicle to the off lock mode. Next, you will need to jump the SCS line using the HDS and wait more than 1 minute for the system to initialize. After ensuring the SCS service check system line is jumped, disconnect the PCM connector A, 51P. The next step involves checking for continuity between 2 test points: brake booster pressure sensor 3P connector number 3 and PCM connector A terminal number 19. This check is important to ensure that the VCC6 line is intact without any breaks or interruptions. If continuity exists, you will need to substitute a known good PCM and reevaluate to determine if the symptoms persist. If the readings do not indicate continuity, you must address any open circuits in the VCC6 wire, highlighting the importance of maintaining proper electrical connectivity in the system. In the 5th troubleshooting step, follow similar initial steps as in the previous step by turning the vehicle to the off lock mode and jumping the SCS line. After waiting more than a minute for the initialization process, disconnect the PCM connector A, 51P. You will now check for continuity between brake booster pressure sensor 3P connector number 2 and the body ground. This step is essential for identifying any shorted wires in the MP-MON line. If continuity exists, it indicates there's a short in the MP-MON wire that must be repaired immediately. Conversely, if you find no continuity, substituting a known good PCM is necessary, similar to previous diagnostics. This substitution will help ascertain if the original PCM is malfunctioning. Carrying out this step is critical for thoroughly evaluating both wiring integrity and potential component failure. After completing all necessary repairs related to the DTC P0557, it's time for final repair verification. Begin by rechecking the system's operation to ensure that all functionalities associated with the brake booster and braking system are working correctly. It's also critical to confirm that the DTC code has cleared from the vehicle's memory using the HDS. Ensure that there are no additional diagnostic trouble codes present that could indicate lingering or new issues. This verification process is key to ensuring that the problem has been fully resolved and that the braking system operates at optimal levels. By conducting these checks, you will ensure that the vehicle is safe to drive and that the repair has effectively addressed the initial concerns associated with DTC P0557. Preventive maintenance is essential to minimize the likelihood of encountering DTC P0557 and its associated issues. Regular inspections of electrical connections related to the brake booster pressure sensor can help identify potential problems before they lead to significant faults. Additionally, routinely testing the functionality of the brake booster pressure sensor itself will ensure that it works as intended and that the system provides accurate readings. Keeping an eye on warning indicators on the vehicle's dashboard is also vital, allowing for early detection of potential braking issues. Implementing these preventive measures can improve the overall longevity and reliability of the braking system, helping maintain safety and performance for Honda Pilot owners. In conclusion, the DTC P0557 signals critical issues relating to the brake booster pressure sensor circuit. Understanding the implications of this diagnostic trouble code is vital for maintaining vehicle safety and performance. The troubleshooting steps outlined provide a structured approach to diagnosing and rectifying issues tied to this code effectively. Emphasizing preventive maintenance practices can further assure that the brake system operates reliably. By actively monitoring and addressing any abnormalities in the braking system, Honda Pilot owners can ensure a safe driving experience while also prolonging the life of their vehicle's braking components. Please like and subscribe to the channel. See you next time.